So the third method, today's method, I stress it's no more than a change. It's really no more than a change of language. And I feel a little guilty about the whole business because it's, instead of going more deeply into studying these equations, what I'm doing is it's like giving a language course, and I'm teaching you how to say hello and goodbye in French, German, Spanish, Italian. It's not going very deeply into any of those languages, but you're going into the outside world where people will speak these things. So here's an introduction to the language of decoupling, in which some people is the exclusive language in which they talk about systems. Now, I think the best way to, well, in a general way, what you try to do is as follows. You try to introduce new variables. You make a change of variables. I'm going to do it just 2 by 2, just to save a lot of writing out. And so let's call the change. It's going to be a linear change of variables because we're interested in linear systems. So the problem is to find u and v such that something wonderful happens, such that when you make the change of variables to express this system in terms of u and v, it becomes decoupled. And that means the system turns into a system which looks like u prime equals k1 times u and v prime equals k2 times v. Such a system is called decoupled. Why? Well, a normal system is called coupled. Let's write it out what it would be. It would look like, I can't use let's not write it out. You know what it looks like. This is decoupled because it's not really a system at all. It's just 2 first-order equations sitting side by side and having nothing whatever to do with each other. This is 2 problems from the first day of the term. It is not 1 problem from the next to last day of the term, in other words. To solve this, all you say is u is equal to some constant times e to the k1t, and v equals another constant times e to the k2t. Coupled means that the x and y occur in both equations on the right-hand side, and therefore you cannot solve separately for x and y. You must solve together for both of them. Here I can solve separately for u and v, and therefore the system has been decoupled. Now, obviously, if you can do that, it's an enormous advantage, not just to the ease of solution, because you can write down the solution immediately, but because something physical must be going on there. There must be some insight. There ought to be some physical reason for these new variables. Now, that's what I plan to start with. So my plan for the lecture is, first, to work out in some detail a specific example where the decoupling is done, to show how that leads to the solution, and then we'll go back and see how to do it in general, because you will see that as I do the decoupling in this particular example, that particular method, though it's suggestive, it will not work in general.